So good morning students. So in the previous video we had seen about the transient analysis. So what are the how your inductor and capacitor are going to behave under initial conditions and final conditions we have seen. Now we'll go for the initial conditions in the circuit. What is the procedure to follow in your initial conditions in the circuit and the problems related to that. So first is the initial conditions in the circuit is we are going to take a waveform there, and before closing of the switch, before applying the waveform, what is going to be the time duration what we are going to take. So suppose B is going to be the point before applying this waveform to the circuit. We say that the time duration is going to be t is equal to 0 minus, and at t is equal to 0 plus 0 we are going to close the switch. That means we are going to apply the signal to the circuit. So after some duration we want to see what is going to be the value. So that means that at point A we want to see what is going to be the value of the current or voltage across a particular element because of the signal what I have given to the circuit. So at point A we say that it is going to be t is equal to 0 plus, and point B it is going to be t is equal to 0 minus. That is closed before closing the switch it is t is equal to 0 minus. After closing the switch it is going to be t is equal to 0 plus. So now we are going to see what are the procedures for evaluating the initial conditions there. So for procedures for evaluating the initial conditions, that is to find out the voltage and current in the circuit, we are going to draw an equivalent network there. So where the equivalent network is going to be drawn at t is equal to 0 plus. So first step is, suppose if it is going to be an inductor. So what we are going to do an inductor is, for the initial conditions, your inductor is going to behave like an open circuit. So replace wherever inductors are going to be there, replace the inductors with an open circuit. Or if there is going to be an initial current that is going to be present in the inductor, you have it as the current sources is going to have the value of your current. That is what is going to be the initial current that is the inductor is going to carry. That current source value you have to draw at t is equal to 0 plus. Next is, if there is going to be a capacitance, what we are going to do is we are going to replace all the capacitors by a short circuit there. And if there is going to be an initial voltage that is going to be present across the capacitance, that voltage is going to be represented as V0 is equal to Q0 by C. So here in this case, replace the capacitors by a short circuit. So suppose if there is going to be resistors, the resistors are going to be left as such without any changes, because it doesn't exhibit any behavioral change there. Next is, I will see the problem there. Find I1 of 0 plus and IL of 0 plus. The circuit is going to be is in steady state for t less than 0. So when it is going to be in steady state, we know that under steady state condition your inductor is going to act like an open circuit. So here the circuit is in steady state when t less than 0. That means the switch is going to be in the open state. So t0 minus, that means that switch is in the open state and your inductor is going to behave like an short circuit there. So your inductor is going to behave like a short circuit. So what they have asked in the problem is your I1 of 0 plus and IL of 0 plus. So to find out, first we should find out what is IL of 0 minus. So to find out your IL of 0 minus, we know that your IL of 0 minus is nothing but we can find out using your current divider rule. Your current divider rule is nothing but your total current into opposite resistance divided by your total resistance there. So I can write it as your IL of 0 minus, the initial condition that is going to flow through this inductance is going to be your total current into opposite resistance is going to be 1 divided by a total resistance is going to be here 2 divided by 2, it is going to be 1 amperes there. We know that the current through the inductor cannot change instantaneously, so we write it as your IL of 0 plus is equal to IL of 0 minus is equal to 1 amps. So we are going to write it as 1 amps there. Next is, they have asked you to find out your, now we have found out IL of 0 minus and IL of 0 plus. Next condition is, they have asked you to find out your IN of 0 minus. To find out your IN of 0 minus, your total current that is going to come here is going to be your 2 amps there. Okay. So this is your node. So if I'm going to take this as node B, the outgoing current is going to be IL of 0 plus. So if I'm going to apply my KCL at node B, so your incoming current to this node is going to be your 2 amps is equivalent to your outgoing current is going to be I1 of 0 minus plus IL of 0 minus. So we know that your I1 of 0 minus is equivalent to, here we are going to have your IL of 0 minus is going to be 1. So it is 2 minus 1 is going to be 1. So I1 of 0 minus is 1 amps there. So next is, this is your I1 of 0 minus is when the switch is going to be in the open state. So when the switch is going to be in the closed state, what we are going to do is, that we will see it now. So here in this case, when the switch is going to be in the closed state, if the switch is going to be in the closed state like this, so here your 2 amps current will flow like this and no current will flow through this part of the circuit. That means that your I of 0 plus is going to be 0. So when I of 0 plus is 0, we can say that your current has changed from 1 amperes to your 1 amperes to 0 amperes. See here the condition is when the switch is closed, this is going to have a short circuit path, low resistance path, so compared to this path there. So as a result what happens is all the current will flow through this path and no current will flow through this I1 of 0 plus there. So as a result we can say that I1 of 0 plus is going to be 0 there. So here we can see that your IL of 0 plus is equivalent to your current divider rule 2 into your 1 by, so 2 into 1 divided by 1 plus 1, that is 1 amperes there. And next is, we know that the current across the inductor cannot change instantaneously. IL of 0 plus is equal to IL of 0 minus, that is 1 amperes. And next is at t is equal to 0 minus, applying your KCL at the node B, we saw that the total current is going to be 2 minus 1, it is 1 amperes. And next is at t is equal to 0 plus, the switch is going to be just closed. If switch is going to be closed, that means that all the current will flow through the switch, and in that case we will be having no I1 of 0 plus. So I1 of 0 plus will be 0. That means that the current will change from I1 of 0 minus to I1 of 0 plus is 1 amps to 0 amps there. So we say that the current in the resistor abruptly changes from 1 amps to 0 amps there. So this is your first problem there. So second problem is find Vc of 0 plus. So find Vc of 0 plus is, assume that the switch was in the closed state for a long time. So was in the closed state for a long time means it is your steady state. So steady state means your capacitor is going to behave like an open circuit. So it is going to behave like an open circuit. I can redraw the circuit like this. So this is going to be your 1 ohms. So here this is going to be your 1 ohms, and you are going to have your Vs voltage to be present here. This is going to be your 5 volts, and the current that is going to flow through this is going to be, when the switch is going to be closed for a long time, means here initial condition is I of 0 minus. So I want to find out what is Vc of 0 minus. So to find this Vc of 0 minus, I have to find out what is going to be the drop across this 1 ohm resistance. So your Vc of 0 minus is equivalent to, we know that I of 0 minus into 1 ohms there. So if I am going to find it out, your I of 0 minus is nothing but your total current. Total current is going to be, sorry, total voltage is going to be 5 divided by your total resistance is going to be 1 plus 1. So into 1. So that is nothing but 2.5 volts. So we know that when Vc of 0 minus is going to be 2.5 volts, when the switch is going to be in the open, that is after that the switch was in the closed state for a long time. Now we are going to open the switch. When it is going to be opened the switch, it is going to be Vc of 0 plus. We know that the voltage across the capacitance cannot change instantaneously. So we write that Vc of 0 plus is equivalent to Vc of 0 minus is equivalent to 2.5 volts. So this is how we are going to write it there. So you can see that first your switch was in the closed state for a long time means it is a steady state. Steady state means capacitor is going to act as an open circuit. So now we first to find out your VC of 0 plus, first we will find out what is VC of 0 minus. So what is VC of 0 minus? It is nothing but the drop across this resistance R2. It is I of 0 minus into R2. So here we write VC of 0 minus is equal to I of 0 minus into R2. Next is VC of 0 minus is equal to, how to find out your I of 0 minus? It is your KVL if I apply, it is Vs divided by R1 plus R2 into R2 here. So that is nothing but 2.5 volts. Since the voltage across the inductor cannot change instantaneously, we can write Vc of 0 plus is equal to Vc of 0 minus is equal to 2.5 volts. So this is your second problem there. So next is your third problem. Find IL of 0 plus and Vc of 0 plus. So we say that the circuit is in steady state with the switch in the closed condition. So if the circuit is going to be in the steady state, what we are going to draw is, we are going to have, this is going to be your 2 ohms. So this is your closed switch. So your capacitance is going to act like an steady state, means it is going to act like an open circuit here. And now we are going to have your resistance to be here 3 ohms. And your inductor is going to act like a short circuit. So here you are going to have your voltage to be 5 volts. So here the current is going to be your IL of 0 minus, your initial condition there. So that is your IL of 0 minus. So IL of 0 minus is the current that is going to flow through this inductor there. So here in the steady state means the switch is going to be closed there. So first we will find out the initial current. So initial current is nothing but your IL of 0 minus is equivalent to 5 divided by your total resistance is going to be 2 plus 3, that is equivalent to 1 amps. Is going to be the initial current that is going to flow through your inductance. So we can write IL of 0 minus is equivalent to IL of 0 plus is equivalent to 1 amperes there. So now we have found out. Next is we are supposed to find out your VC of 0 plus. So VC of 0 plus is nothing but when the switch is going to be closed. So switch is going to be closed means the drop across. So VC is nothing but the voltage at this point. So voltage at this point is nothing but the drop across this 3 ohm resistance. Now if I am going to redraw the circuit, here I will be having it as like this. So this is going to be 2 ohms. This is going to be a 3 ohms. This is your 5 volts. Your current is going to be I. So your voltage drop here is nothing but the voltage drop across this 3 ohms is going to be your VC of 0 minus. So here in this case, this is your I of 0 minus. So VC of 0 minus is going to be I of 0 minus into 3. So here I of 0 minus is nothing but 5 divided by 5 is going to be 1. So 1 into 3 is going to be your 3 volts there. So here in this case we are going to have your VC of 0 plus is going to be your 3 volts. So 5 divided by 5. So in this case we are going to get it there. So we can see that so first your inductor is short circuit, then your capacitance is going to be open circuit. Now we can see that IL of 0 minus is going to be the total current. It is 5 divided by 2 plus 3, that is 1 amps. So here in this case VC of 0 minus is equivalent to your total voltage 5 into 3 divided by 3 plus 2, that is 3 volts. We know that the voltage across the capacitance cannot change instantaneously. So we can write it as VC of 0 plus is equivalent to VC of 0 minus, and the old current across the inductor cannot change instantaneously. So we write it as IL of 0 plus is equivalent to IL of 0 minus, that is 1 amps there. So that is what we have got here. Thank you.